Hello, everyone. Thanks for joining us today. Welcome to the latest edition of ASTERRA's 2026 webinar series. We've got a real interesting show for you today. Just want to let you know we'll be doing these on a regular basis, and each one of these webinars will have a different focus. So even if you listen to this one, you should tune into the next one in this series because we'll be talking about something different. We'll be analyzing how leveraging advanced satellite technology combined with traditional boots on the ground methods helps utilities achieve a faster return on investment and also does the work more efficiently. Next slide, please. I'm Paul Gagliardo. I'm the host of the Water Entrepreneur Podcast, and I'll be the moderator of this webinar discussion. We have two panelists today, Tony Popolo, manager of the Water Asset Management Program at McKim Creed. Hey, Tony. And we have Bruno Tume, Director of Sales in the Americas for ASTERRA. Hey, Bruno.
Hey, Paul. Hey, everyone.
Next slide, please. So on the agenda today, we'll discuss traditional leak detection methods, benchmarking metrics, how satellite technology works alongside traditional boots on the ground methods, and then we'll present some case studies. If you look to the left-hand side of your screen, there's a poll question listed on the panel. If you all vote, we'll announce the results at the end of the webinar. Next slide, please. So ASTERRA and McKim Creed have worked together extensively over the last 5 years. They've collaborated on over 100 projects, analyzing 10,000 plus points of interest, achieving over a 50% success rate, and that found leaks that reduced water losses for customers by over 10,000 gallons a minute. Very impressive work. Next slide, please. So Tony, McKim Creed has been doing leak detection for many years. Can you describe the traditional process you guys used before you started partnering with ASTERRA?
Absolutely, Paul. So traditional leak detection usually encompasses covering your entire distribution system, whether that be in full or just periodically over periods of time, with recurring inspections using amplified noise equipment to then understand where there is leak noise in the distribution system and narrow that down to pinpointing that leak for remediation efforts. With standard traditional boots on the ground approach, we would be going through the system every point to point and typically basing that on pipe material and density of the areas and the methodology that we would take with inspecting the system. And then understanding where that leak noise is deriving from and coming in, putting the final mark on the ground, and reporting that back to the client so they can come in and make those repairs. Generally, that's happening from a systematic approach from one end of the system over to the other, or sometimes you may start in hot spots and then make your way through the system, eventually covering every aspect of the system. As you can imagine, that can take quite a long time with some of these water distribution systems that can be quite large and quite a man effort or technician effort that is required to do that in full on a yearly or recurring basis.
Hey, Tony, I had a question. Do the utilities tend to kind of direct you to a particular location, whether it's a place where they have had leaks in the past, or maybe they think they have a high probability of failure? Do they kind of, do any pre-work, if you will, to or do they just say, hey, start at the park on this end of town and head north? How do they do it?
Good question. And really it comes in across the board. Some places leave it up to our expertise to try to help guide where that action should start and finish at. And then you always have, a group of utilities that out there that know where the problems always are, or want to more often than not tell you, hey, we just had a major leak over here, we repaired, and then you come in 2 weeks later and they're saying, go start over there, which they fixed the leak, right? So it's moved down the line somewhere else. So it kind of varies across the board, but we try to help guide that as best we can, given we're going to be covering the whole thing, and we hope we get lucky with the area that has the most leaks first.
So do you typically work with the operators or the engineers?
Again, a mixed bag of results here. You know, a lot of these programs are derived from the operators, showing that we've got problems out there. We're trying to keep up and fix these issues. So we want to change from a reactive to a proactive program. And then it's tasked with the engineers at the utilities to help build that program out, solicit for those services, and then bring in a firm that's qualified to do the inspection for that very nature and to achieve what the operators are looking for.
Do you ever work with utilities that kind of have their own leak detection crews and kind of work side by side?
Yeah, very frequently we have a lot of groups that have their own equipment. Sometimes that equipment is very dusty because they haven't pulled it off the shelf in quite a while, but others that have used it on a regular basis. More often than not, though, those utilities tend to use them in a very reactionary approach, where they will use it when they need to have a surfacing leak and come out there to try to identify where that's sourcing from so they can make those repair efforts. But a handful are doing it on a regular basis.
Great. Thanks, Tony. Next slide, please. So I want to look at some benchmarking data. As Tony was talking about, there's a traditional methodology, and then we'll talk in a few minutes about ASTERRA's satellite-directed program. So when we look at the traditional boots on the ground and the ASTERRA targeted method, you can see that marrying this new technology with traditional methods, performance has increased significantly. And one of the reasons for this is that leaks are clustered. They're not evenly distributed throughout the distribution system. So if you can find the areas where there's a higher concentration of leaks, you can increase your efficiency, find more leaks per day, find more leaks per mile inspected, and come up with, and this is the way you come up with a better return on investment. So we have two different sets of data here. The traditional boots on the ground, we did a metadata analysis of over 2,000 projects. And those 2,000 projects, about 19,000 leaks were found. And on average, and this was from 3 different traditional boots on the ground leak detection contractors, we found 1.3 leaks per crew day and 0.3 leaks per mile physically inspected. I think one of the things you'll see between these two data sets also is that the miles inspected per crew day is a lot higher for the traditional method than for the ASTERRA method. And this is because some of the best practices that ASTERRA has developed. And also the, a corollary to that is the listening points per mile accessed. Because the traditional methodologies have typically gone through the system faster, they're accessing less access points than the ASTERRA methodology. As you can see, the non-surfacing leaks is about the same number, 80, 90%. Leak size a little bit higher for ASTERRA. And the cost per leak found because of these efficiencies is lower for ASTERRA. On the ASTERRA side, we looked at about 800, 900 projects. And in this particular case, and we've more than doubled the number of projects and the number of leaks found, but we're looking at about, in this case, about 87,000 leaks found. And we're looking at a number of 5.5 leaks per crew day and 3.4 leaks per mile physically inspected. So again, you can see that using the ASTERRA remote Earth observation satellite technology to identify where there are these likely leak locations, it increases the efficiency of the field inspectors to find the leaks because we're focusing on areas where there are concentrations of leaks, which then increases or increases the return on investment, decreases the time it takes to find the leaks, and increases the value proposition for the utilities. Next slide, please. So Bruno, can you explain how the ASTERRA remote Earth observation technology works and talk about some of the results you've achieved?
Yeah, sure, Paul. I'd be happy to. So, we've been selling here at Astera ever since 2016, and the technology that we're using today is called L-band synthetic aperture radar, or SAR for short, which you can see there at the top bullet of the screen. Basically, what synthetic aperture radar is an active imaging radar system that can typically be mounted on either satellites or aircrafts. At Astera, we've actually used both methods before, satellite and aircraft, although we are primarily today using the synthetic aperture radar mounted on satellites. Right? On top of that, we actually use a wavelength called L-band. Right? L-band is basically, the L is standing for long. It's the long wavelength in the magnetic spectrum. There are other bands that are out there, C-band and X-band. But one of the reasons why we're using L-band is because it gives us that depth of penetration through the Earth's surface. This allows us to see non-surfacing leaks. So this is the core technology that's being used today. Have we used the airborne method before on an airplane? Yes, we have, primarily outside of the United States or North America. But the primary method that we're using today is the satellite method. It covers a very, very large area. We're actually able to cover up to approximately 1,400 square miles in a single snapshot, which is huge. If you imagine that, we can basically cover essentially 12, maybe 20 even municipalities, even in one single snapshot. So it's very cost effective for that reason. And it's completely non-invasive. Right, L-band is working up in space. This is literally happening as we speak right now. There are satellites orbiting the Earth from pole to pole as we speak, and we're essentially just acquiring that imagery and doing the analysis on that. Completely non-invasive. We're basically providing that data to Tony here at McKim Creed so that he can send his crews out there to go do the pinpointing method, that field investigation that he was talking about earlier. So this is really how the core technology works. We can penetrate through pretty much anything for the most part. What gives us some trouble there would be mostly metal and also water, right? So penetrating through like a big body of water, it's not something we can do. At the end of the day, what we're looking for is the soil moisture at the end of the day. And even taking it a step further, it's the conductivity, right? It's that water element, like the chlorines, the chloramine, the fluoride, if it's on the wastewater side, and really analyzing that conductivity when it comes into contact with soil. So when those chemicals are coming in contact with soil, we're basically looking at that conductivity and isolating those areas within the system, saying, hey, you've got water leaking into the ground in this area, you probably have leaks. And so then Tony can then take his team out there to go verify exactly where that leak is. Right? Again, we've been selling ever since 2016. We've got customers all over the world. We're going as far as Guam, all the way to Raleigh, North Carolina, right? So customers all over 600 customers to date, many projects within there, water, wastewater. The applications that we can use this technology for are pretty endless. We've actually expanded into dams and levee monitoring as well. You can use this technology to even predict landslides. So I think the possibilities here are quite endless, although the majority of our projects today have been on the water side, but we're looking to break through beyond that. You can see we've been able to verify, almost 200,000 leaks today worldwide. Amazing. That number continues to increase daily. I wish we had sort of like a daily tracker where we could just keep seeing that number increase regularly. But it's been pretty awesome. I've been here for a little over 5 years, and it's just crazy to see how we've expanded from, the 50 customers that we had to where we are today. It's pretty awesome. And not only that, winning the Innovation Award, as you can see there, actually the year that we won it, which I believe was 2021, I could be maybe off, was the first year that the AWWA even had an Innovation Award. So it's pretty cool. We were the first ones to win that.
We got next slide. I think you have a couple more slides there, Bruno, to talk over.
Absolutely. So I got excited. So going back to a little bit more about how the technology works, right? You can see that image there on the left is an image actually of the Bay Area. in California that is covering roughly 1,400 square miles. So we're able to cover, Sacramento and nearby cities all in that one swath, which is pretty awesome. We actually did a project in Green Bay, Wisconsin area where we were able to cover, I think it was somewhere between 8 to 12 different utilities in a single snapshot. So that's again a huge benefit that we have. I talked about the sensor that we're using, L-band, the fact that we're able to penetrate through that Earth's surface. We can penetrate up to about roughly 10 feet, depending on soil type. So this is something I didn't touch on earlier. When it's drier, arid soils, we can actually go potentially even deeper than 10 feet, versus when it's more of a clay soil type, it's probably going to be more closer to about that 10 feet range. We have gone as deep as even 30 feet in some areas before. So L-band is very, 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 very helpful for us for that reason, versus when you're looking at like a C-band or an X-band, which we don't use, you're talking more at the surface level. You're talking more just vegetation there at that point. I talked about the different algorithms that we have, right? So we do have one for water. We have one for wastewater. We also have one for soil moisture, right? So that would be probably used more on looking at wet areas under roads or railways, or dam monitoring for seepage, levees, property, things like that. So the applications are pretty endless. We actually found lithium even using the technology, which is pretty crazy. Now, we're not selling that or using it for anything today, but just so you know, maybe one day we'll find gold.
And next slide, please.
Awesome. So, sorry, Paul, were you going to say something?
So you.
Awesome. So, leveraging the satellite information for faster ROI. Again, so why this technology is so helpful and why you're seeing both Tony and I here together is, and we're not competing with each other. We're very much helping each other. All right. We know, ASTERRA knows that, doing a boots on the ground using traditional equipment to find leaks is the best way to find leaks, truly. Hitting every asset within the system, opening those meter boxes, looking at the hydrants and the valves and all of it is the best way to do leak detection. But the only issue there is making it more efficient, more effective. There's some large cities out there. I mean, I live in San Diego, California. If I'm thinking about doing leak detection traditionally with that equipment that I was just talking about in the city of San Diego, how long is that going to take? Right? I mean, it could take, quite frankly, years to get through the entire system. And it doesn't matter if you're sending one person out there with equipment to look for it, or even 3, 4, or 5, it's still probably going to take potentially multiple years to get through the entire city to be able to find leaks. Right? If I start at point A and need to get to point D, by the time I get to point D, it's probably been 2 years and there's already more leaks that I now need to go back and address in point A and B, right? So where we come in is we take that scan and we can get you to those, what we call points of interest, likely leak locations, whatever you want to call them, to basically say, hey, Tony, go ahead and send your team out there to just these areas where we're already seeing the water leaking with our technology. And instead of walking thousands of miles in San Diego, you can walk 100. And it's going to save you a lot of time. It's going to save you a lot of money, and the team's going to be motivated and happy because instead of finding, 1 leak a day, they're finding 3. Right. So this is really where that return on investment comes from, is the efficiency of what the satellite technology can bring to your system and to your leak detection program.
Great. Thanks, Bruno. And Tony, from the field inspector's perspective, how have things changed for you since you began to partner with ASTERRA?
Yeah, and to Bruno's comment, we may have already struck gold, right? That's kind of the way we feel sometimes. It's really interesting. Years ago, we've been doing this traditional inspection of leakage on systems for quite a long time now. And even with myself in the field many years ago, I remember talking with other technicians as we'd go about the traditional way of inspecting systems and say, if we could just snap our finger, we wish we could just go to where all the leaks are, because that's the exciting part, right? There are many days of monotonous and mundane, quiet days where you're not coming up on a leak, and the stats show that. And so it was, very appealing for us to say, hey, there's a technology out there that can put you on those leaks. And even in some of those senses where we go to areas of interest that have been outlined from ASTERRA, and all of those connections could be quiet, there are limitations in the acoustic technology that can prevent you from finding a leak in the system. The soil saturation can be coming from a very, very small leak. The density of the system and the assets that are there to inspect with the traditional acoustic methods can be limited. And so there are some times that we encounter that. But overall, the excitement has increased tremendously because we are finding more leaks on average by addressing these areas of the system that have been highlighted as soil saturated areas that give that signature for chlorine potable water in the area. And so, it's really improved not only the mindset out there and the excitement, but also the efficiency, right? I mean, talking about covering ground that's not needed, how many days are wasted of inspecting assets that are quiet when we could go directly to the sites that have leakage and spend that time actually pinpointing. Identifying noise in a system as easy as just saying, do you hear something or not? The real fun and expertise comes in to pinpointing that to the exact location where that noise is sourcing from. And so ASTERRA really makes that efficient in telling us, hey, within this 1,000-foot area of the distribution system, we're getting this signature back that we've got potential leakage in the area. And it takes our time, spent needlessly in areas where they're not going to find leaks to, we're honing that in onto the area. And my boss is a big proponent of using the methodology and thought process of hunting and not hoping. And when you're covering your full system, you're doing a lot of hoping. We hope that we find those big leaks on day one. When you're using data-driven solutions to identify where you're going to have the most efficiency, we're more now hunting where those leaks are and finding which one of these ASTERRA POIs is going to be the big hitter, because not all of them are big leaks. We find lots of great leaks through the ASTERRA POIs, but we do find also those very large ones, and we're able to get to them a whole lot faster than we would if we were doing the traditional, inspection across the full system.
Great, thanks. Next slide, please. So we're going to talk a little bit about case studies. Can you guys tell us about some of the specific projects you worked on, results, maybe a little anecdote about what was interesting about them?
Yeah, I'll take this one and talk about what we did in Jackson, Tennessee, for the JEA Authority. This was a really unique project, and this client has a lot of a mixed system set up. So there are some areas of concentrated, urban areas that also have some remote sections of the system as well. And so it takes a little bit of a different approach when you're looking at those systems from a leak detection standpoint. But when you're utilizing the ASTERRA points of interest, it takes some of that questioning out and kind of lets you focus in on where those leaks are coming from. One of the things that we saw that was interesting with this project was that we found some leaks that were surfacing much farther away outside of the points of interest that were outlined from ASTERRA, only to come back to tracking them down to where the actual source of the leak was in the ASTERRA POIs. And so there's a lot of times where Bruno hit that we're only penetrating the ground up to that 10 feet or so, but we may have pipes that are significantly deeper than that have been leaking long enough to saturate that soil. So we don't have to necessarily have a leak at the pipe in 30 feet that we have to see. We just need to see that soil has been saturated by that leak. So we're able to find leaks on pipes that are really deep because it has saturated the soil. And so this was one of those where we found some water running into a creek. It tested positive for chlorine signatures, and then traced that back to the source being within one of the ASTERRA points of interest. The other side of what we're doing with a lot of these groups that we're working with ASTERRA on is helping educate them on the process of what that acoustic leak detection process looks like. And so, helping them understand, when we do go to these areas of interest outlined from ASTERRA, we need to not only know how to acoustically identify leak noise, but then how to pinpoint that, because more often than not, we've got leaks in those areas that need to be pinpointed. And so showing them the technology that's available to them to then take this in-house and do some of this stuff on their own more efficiently, and what we're always looking for, reducing that leak runtime. There's only so many McKim Creed leak technicians out there, so we can only get these projects so fast. So the more opportunities we have to train other folks on using that equipment and how to utilize, the areas of interest, which helps them as well. When they have ASTERRA points of interest to focus on, they can really then, take the limited personnel they have to focusing on where those leaks are occurring at, and not trying to just cover their full system. And this is a large system that would be quite hard to do that on a regular basis. And so now we're taking those leaks to be found in these areas from ASTERRA, we can then, instead of doing it multiple times throughout the year of covering the system, or doing the full system investigation once a year, you can then scan the system multiple times for the same amount of money and half of the time that it takes to inspect it. And so that's one of the things that we're seeing here in Jackson, with the size of the system they have and some of the rural natures of these leaks. With a system like this, you would have to spend quite a bit of time in those rural areas being more comprehensive. And the more you do that in areas that aren't leaking, the more time that's wasted. When there's not a lot of fittings available for typical asset inspection, you then need to be walking over the lines and ground mic and probing over these lines to find leakage. Well, when we have that narrowed down to smaller segments that we know are showing signatures of water saturation, we can do that in the small areas that are needed and not waste as much time. So that's another key component that was part of this project. I think we've got
Great. Next slide, Bruno. Why don't you give us a little story about your case study? Next slide, please. There we go. Thank you.
Awesome, sure thing. So this one here is a project with Henry County, Virginia. We've been working with Henry County for a number of years now, actually, but this one is specifically results from a couple of years ago. And the story with Henry County is that they just had trouble with their non-revenue water. It was rising in a matter of 12 months. They started at 22% and it rose all the way to 33% in that time period. And so they were kind of scrambling, trying to figure out what is going on. Is it a billing issue? Is it a leaks issue? What's going on here? They ultimately determined that it was because of leakage. And so they were trying to figure out what technologies are out there. Should we use one? Should we use a combination of some to be able to attack this issue? So after evaluating multiple technologies that are out there, they decided to do multiple satellite scans and then use their own internal crews actually to go out there and do the investigations in the data, in the points of interest that we provided through our data. All of this was done on the water side, on their distribution side, and is in a pretty rural area. So as you can see, they have 374 miles of pipe, all on the water side. It's a combination of mains, service lines, and also customers' service line leaks on the customer side. And we took 2 scans of that system. Now, once we provided the data to Henry County, they have their own teams that they use. I think it was a crew of maybe 2 people with traditional equipment, listening sticks that they would use, and correlators to go out there and do the investigations. And it took them a number of months to do so. I think it was about 6 months that they spent in the field actually doing investigations within a point of interest to pinpoint these leaks. And the results were just phenomenal within that time frame, and the return on investment was significant. So as you can see here, we were able to find 311 leaks within their system through this. So you can imagine that their decrease in non-revenue water loss percentage from 33 went way down, even just in this service alone. Now, if you're looking at the leaks that we found, out of those 311 leaks, 259 were actually on the utility side. So that was a combination of mainline leaks, service line leaks, some leaky hydrants, some leaky valves, things like that. And 52 were on the customer side of the meter. So we actually will identify customer side leaks as well. But in this scenario, the ratio between utility side leaks and customer side leaks was very much favorable for Henry County, and they were able to recover a lot of water through that. Now, we're going to find leaks that are surfacing and also leaks that are non-surfacing. This was a pretty interesting study here where 135 of the leaks that we found out of that 311 were non-surfacing leaks. 135 non-surfacing leaks in a short period of time like that is massive. It's a lot of non-surfacing leaks to go and attack. But believe it or not, that's actually a lot lower than we would typically see on an ASTERRA service. Usually, you're upwards of 90% of the leaks that are found are going to be non-surfacing. This was a unique case where it was closer to maybe 50-50. If I was to take a guess as to why that happened, it would probably be due to the fact that it just took longer to get out into the field and actually do the investigations. It's not like they had a crew of 5-6 people that are going out there. It was 1 or 2 people that are going out there to be able to investigate the points of interest. So if it takes longer, as you know, leaks aren't getting any better. They're just getting worse. Right? And that's why we want to find them as early as we can. Even those smaller 1, 2, 3 gallon per minute leaks, That right there is what's going to save you a lot of time, and what often gets forgotten about when you're talking about the return on investment and the consequence of failure. I mean, what is the consequence of failure for a leak that started at 1 gallon per minute and has now become, a 50 gallon per minute leak, which absolutely can and will happen if you don't address it when it's smaller. So I think Henry County was very, very happy with the service because they were able to attack 135 non-surfacing leaks that were underground that they were completely unaware of, that were smaller to medium in size, but they didn't become big problems. They were able to proactively address those, fix them, and ultimately get that return on investment, specifically 503,000 gallons a day in just the non-surfacing leaks alone. So that's even putting aside the leaks that ended up coming to the surface that were identified, but just the non-surfacing alone, 503 gallons a day, which equated to just under $320,000 in yearly water loss savings. So very significant amount of money that was saved for them, and we continue to work with them on a regular basis doing scans.
Great, thanks, Bruno. Next slide, please. I want to thank everybody for joining us. That's the end of our prepared remarks. You can reach Tony and Bruno through the information that's listed on the slide right here. And I did want to go to the poll question, which was, do you have or have you had a proactive leak detection program? And interestingly, a little more than 40% of those of you who voted have not had a proactive leak detection program, which to me is very interesting. To be honest, I didn't know what to expect from the percentage of folks that have had proactive programs. And proactive could be just sending crews around traditional methodology. It could be an ASTERRA type of program, could be a fixed-based acoustic leak detection program. But fully 40% of you who voted said that you have not had a proactive program. So maybe it's time for you guys to sign up with ASTERRA and McKim Creed. And so now we'll take some questions, and we have a number of those in the Q&A. The first one relates to the benchmarking data, and the question was, what's the depths of the leaking pipes and what materials were there? So as Bruno mentioned, the ASTERRA technology can see 2 to 3 meters below ground. So we're looking at that kind of range. And then the materials, all kinds of pipe, plastic, metal, asbestos cement. So the type of pipe doesn't really matter. It matters more from the standpoint of pinpointing the leak, because the sound generated from a leak on a plastic pipe is lower than on a metal pipe, so it's harder to hear. And also it depends upon the pressure in the pipe. Higher the pressure, the louder the noise. And so, but to answer this particular question, it's any kind of material. It's material agnostic. Bruno, this is a question for you. Does the leak, do you identify just the leak location or the size of the leak?
Yeah, that's a good question. Does it, can we identify the size of a leak or just the location? So the short answer to that is we simply are showing you the location of the potential leaks, not the size of it. And there's a number of reasons for that. One, you got to give us a little bit of grace for using satellites all the way up there in space, 300 miles approximately away from us. So because of how far away that is, it's difficult to be able to see that. At the end of the day, too, we're talking about leak detection here, and we're talking about finding leaks. But the truth is, what we're seeing is the soil moisture. We're seeing that buildup of water saturating the soil, which could be a small amount of water, it could be a medium amount of water, it could be a lot of water. We're not sure. We can just tell you that there's something there. We can tell you that there's water leaking in that area. We don't know the size to this point. As the technology continues to evolve, I think we'll eventually, knock on wood, be able to get to the point where we could tell you something like that. But as it stands today, we can just tell you, hey, within this area, you've got something going on that needs to be investigated further. And then once we get to Tony's part, he can actually tell you approximately, what that size of that leak is until you actually dig it.
Yeah,
Antonio, I was out in the field with some of your folks in New Mexico, and by listening to the noise generated and kind of knowing what the size of the pipe is and what kind of pipe it is, you guys can make some kind of value judgment about the size of the leak before it's dug up. That takes a lot of training, I would assume, a lot of experience.
yes, a lot of experience and exposure to seeing different leaks that were dug up and what we estimated them at, what they truly turn into being. And so one of the things to hit on, can you tell the amount of the leak from the satellite analysis is, a lot of these scans, if they're happening for the first time, there's no telling how long that leak has been running, right? So it's really hard to say that this leak was just pointed up yesterday or it's been running for, a year, and that's what's caused the saturation. So it'd be really hard to use that to say what the amount is. And that's where when we come in and we pinpoint that exact location for remediation, we then give an urgency based on the estimated leakage for that individual location. And that comes from what you talked about, Paul. The size of the pipe matters, the pressure in the system. And then, of course, if we've ever got some sort of visual clue, like if it's hitting a storm drain or a nearby ditch, we can look at that flow rate and give a little bit of a better idea of what that leak size is going to be. But it's never a perfect science. And then until you dig it up, you're never really truly going to know what that was.
So Angelo from Sarasota County is asking about the impact of high water table and how well does the technology work in that kind of an area. So Bruno, maybe you can at first talk about how the satellite imagery differentiates between naturally occurring water and potable water. And then Tony, maybe you could talk a little bit about, is it more difficult for the pinpointing if you've got high groundwater?
Yeah, sure thing. Absolutely. So, and Sarasota, that's in Florida. Actually, at ASTERRA, Florida is one of our most successful states. We've got a lot of happy customers in Florida. I could go on a list of who they are, but high water table does not impact us. We are looking again for a very specific conductivity range, right? And groundwater is different than potable water, which is different than wastewater, which is different than seawater, which is different than reclaimed water, right? And all of those are different. And when those elements each individually come into contact with soil, that conductivity is also different. And we can see that within the algorithm. We're looking for a specific range of conductivity in each pixel within the image, and it looks a little bit different based on that water type. So this is how we're able to differentiate those water types, is through that conductivity. So we can separate, groundwater from regular water. I'll let Tony speak a little bit further on the leak detection side of that.
Yeah, and it's kind of the opposite for us. It can affect our ability to pinpoint that leak. So water is an item that will deaden sound. So when there's a really high water table, there's a leak occurring, that water that's surrounding that leak can cause that noise to be a little bit less intense. And so in areas like that, we'll take some different approaches where we're able to use additional technology such as thermal imagery or water column correlations, where we're actually looking for that noise instead of on the pipe material within the water column itself, which can then transmit a lot farther down the pipelines when you have those environmental impacts that could stop you from hearing leak noise with your traditional sense.
Great, thanks guys. Next question has to do with the impact of topography, and Tony, I think you mentioned this earlier, but if you could share a little bit about that. And there was a follow-on question: has ASTERRA published any papers on this method? There have been technical papers in the literature published, magazine articles, and I think if you reach out to Bruno, he can provide you with copies of those. But Tony, can you talk a little bit about, from a topographical perspective? As we know, the ASTERRA methodology sees the result of the leak, the actual wet soil. But if you have a leak like up on a hill, it might flow down, and the ASTERRA might show the leak in a different location. How do you guys handle that kind of a situation when you're presented with it?
Yeah, and probably the hardest part is convincing that utility operator to dig somewhere that water's not surfacing up. So we, have done this all across different topography ranges, from those sandy soils in Florida to the, mountains of Tennessee and Hawaii even, right? And so what we typically run into with the topography is when we have areas of a lot of relief, we're going to be going above and beyond just to make sure that scan is hitting an area that maybe is being saturated from something that is uphill, and just the water tends to pool further down the area. The same thing happens. I talked about, some of the ones that we are able to see visually hitting storm drains and things of that nature. Well, we may not see that water in the side, the point of interest has been outlined from ASTERRA, because the area that's being saturated is near the leak and it's actually hitting further away. So the water is traveling down. So topography comes into play, but typically it's always with trying to convince them to dig somewhere there's not water surfacing at, because we've got other indicators that are pointing us there, including the POI or the acoustic signatures.
Great, thanks. Bruno, what's the amount of time between, you sign a contract and, you get the satellite image, you do the analysis, and then you send the crews out. Give me an idea about how long that takes typically.
Yeah, it's a great question. It's pretty quick. Basically, from the time that you say go, hey, ASTERRA, go ahead and let's proceed, we're going to go ahead and request that image and receive the image in somewhere between a week to 2 weeks. Could maybe take 3 weeks on the really long end of that. Once we've received that image, give us about another week to do the analysis on the image. So we're talking anywhere between probably 2 to 3 weeks before a utility actually gets their data back. And then as far as getting out there and investigating the leaks, it's just a matter of, if you're using your own team, once we deliver that data to you 2 weeks later, go ahead and go action it immediately. Or if we're going in there, with Tony and his team, we're talking every single day and getting someone out there as quickly as possible. So maybe another week after we've delivered you the data there. So I think the whole process can range anywhere from 2 weeks to 4 weeks on average.
And so, Bruno, are you guys like Elon Musk? Do you have your own satellites, or how do you guys do it?
Yeah, I'm smiling. I love that. Maybe one day. That's the goal, to have our own satellite one day. Definitely. But today we're using commercialized satellites. One Japanese, one Argentinian satellite today. You can look them up. ALOS 2 and Salcom. Those are the two common satellites that we're using today. There's another one called Luton as well. All synthetic aperture radar and L-band specifically.
And how often do they cover the same area?
Oh, great question. So yeah, as I said before, these are satellites orbiting the Earth as we speak right now. It's not like it's programmed for ASTERRA to be taking images constantly. It's actually not taking images constantly. It's being tasked essentially. So I'll use Sarasota for example, just because I saw it in the question. Once Sarasota County says, yeah, go ahead, we'll go to the satellite company. We'll say, hey, once you get there, take that image of Sarasota. Probably take a few days until it gets there, maybe a week. We capture that image, and voila, there we are. So basically, we're acquiring that image upon request.
Right. And Tony, I'm curious, after you get the likely leak location, the points of interest, do you find is there any specific difference that you've noticed between rural areas and suburban or urban areas? I know maybe in urban areas it's more ambient noise, which might make it harder to pinpoint the leak, but do you have any feeling about results, efficiency in rural areas versus urban areas?
Yeah, and it's a good question. It's kind of a double-edged sword. So when we have a dense location, such as urban areas, it gives us more access to the acoustic investigation methods. So we have more appurtenances that are touching the pipeline to inspect and pick up on where that noise is coming from and sourcing from, which would take us longer. in most situations to sound more fittings. And then in rural areas, we have less of those. So if you're just going from the point to point methodology in those situations, it's going to go by a lot faster, but less likelihood of hearing that leak noise. And so in those situations, we tend to advocate for more comprehensive approach of sounding over top of the line in very short intervals, so we can pick up on any noise that you're not going to be able to hear at far distances, especially on large diameter or plastic natured pipe. In those locations are going to be quite difficult to hear that leak noise farther away. And so that could be time consuming as well if you do take that approach. But the dense areas, typically, the more fittings you have, the easier it is to identify those leaks, and the more likelihood that you've got a leak in those areas that is going to be tied to where that pipe changes or has a fitting or appurtenance tied to it.
And this question for both of you, I'm curious if time of year, summer versus winter, makes any difference from the satellite imagery side, and probably more important from the field inspector boots on the ground side. If it was for me, I'd rather go out in the summer because I like hot weather. I'd rather not go out in the winter, but Tony, we'll get to you in a second to see what your guys prefer. But Bruno, does seasonality have any impact?
Yeah, it's a good question. So for ASTERRA on the satellite side, the answer is no. We can do this any time of the year, any time of the day. Doesn't impact us. Now, we can't choose whether we get an image at 8 a.m. versus 8 p.m., right? Once it gets to you, it's going to take the image. But no, those things don't impact us at all. Tony will have a lot more to say on his side.
Yeah, and so we all just want to work in San Diego every day of the year, okay. But definitely an impact. I mean, everything in the cold takes a little bit longer. You start your car up before you go out when it's cold because it takes longer to get warmed up. And in the same way with our bodies, right? When you're out in that cold, you tend to move slow. You're padded with all the different things you got to wear. And it's a lot harder to get those lids off and find, especially when we're working in snowy areas. Those locations are going to take longer in those kind of conditions because assets aren't as visibly available to you like they would be when there's not snow on the ground and things of that nature. So if we have a chance to choose what we're going to work, it's going to be the spring and the fall. It's always going to be the most productive, where people aren't, having to take frequent breaks in that 150-degree heat in the desert in the middle of summer, or having to dig out the snow and things like that to find the assets.
So we've kind of gone over, but I have one more question, and then just so everyone knows, we will respond to all of these questions specifically. I know I haven't got to everybody, and I apologize for that. But Tony, can you give me an idea of the types of equipment that your field crews use? And personally, I'm also curious that, has that, acoustic pinpointing and correlating equipment, has it improved over the last, 4 or 5 years? Is it getting better, or is it the same? Are we still using listening sticks, up to, a guy with a top hat, with the stick to his ear?
Yeah, and the technology has definitely continued to advance, and even as from last year to this year, we're seeing improvements across the board. But generally, we're using amplified technology. So like you talked about with the guy with his ear to a rod, many of the operators out there, they still use that old trick, and you can put your ear to a T-bar handle on top of a valve and hear that noise if it's strong enough. We're taking that noise and we're amplifying it with digital enhance, and also the ability to narrow down the frequency range, because with different size pipes and material pipes, the frequency is going to be in different ranges. And so we can do that to hone in what is fitting best for that area of the system. And then beyond that, when we're into the pinpointing phase, we're using things like correlators, and the correlation technology has advanced enough to where generally it used to be a very only real-time correlators, which means you had to be there in the moment and use devices that were tied together with radio frequencies to get their time synchronized. And now you have the ability to set out post-process correlating technology, and even technology that's tied into modems that can correlate all the time and send you back data when they have hits. So that technology is definitely advancing. And then we're getting into using thermal technology and things of that nature now, which is getting more advanced every day and able to penetrate and have stronger signals where we can see that leakage in different ways.
Great. Thanks. Well, Fabulous, guys. I really appreciate, all the great insights. And again, thank you to our attendees. Appreciate all of you folks hanging in there the whole time. As I said, we will curate all of the questions and make sure we're back to you and answer all the questions as well as we can. Feel free to reach out to Tony or Bruno, and we'll get you to the right place. There's the information there on the screen. But again, thank you very much for listening, and tune in again next month, and we'll have a new show with new people, and we'll talk about some other new information related to leak detection. So thank you very much. Appreciate you listening.
Thanks, everyone.
Thank you, everyone.